Hey everyone, welcome back. I hope you all had a good spring break. I'm making this on Monday. You probably won't watch it till later. It is pouring outside right now. Hopefully you guys are staying busy and all that good stuff. Today we are going to do some more notes. I want to do 3 pages is my goal to get through today. And then that leaves really just a couple pages left for your last video. And then we are done with momentum. So I will give you a test on momentum that's coming up next week. But I'll give you more details on that later. So today I want to talk about elastic versus inelastic collisions. So all in this chapter, we've been talking about collisions. We said, okay, things collide. When they collide, we can look at that collision in terms of momentum, and we know that momentum is conserved. Whenever there is a collision, whether it is elastic or inelastic, momentum will always be conserved. There are 2 assumptions that we're going to make. We are going to assume that it is a closed and isolated system. They will always be closed and isolated. You do not have to worry about what if they're not. Closed system means that no mass enters or leaves, and an isolated system means there's no external forces. So obviously there's forces, but all of the forces are internal. So the force on the one object on the other versus the force on the other object on the first one would be internal forces. So we can say that the linear momentum is always conserved in a closed, isolated system, whether or not the collision is inelastic or elastic. If, though, it is elastic, then that means the kinetic energy is also conserved. So elastic conserves kinetic energy. Inelastic does not conserve kinetic energy. Both of them conserve momentum. So think about it. Easy example, if you are holding a ball and you drop it, if it bounces back to the same height, that means that it was elastic. It has the same amount of kinetic energy. No energy was lost. It was able to go all the way back up to the same height. If it does not go to the same height, then some energy is lost, and that would be inelastic. Both of them, however, conserve momentum. So elastic collisions conserve energy and momentum. What you have is, here's a little picture. This is my initial situation. Object M1 is traveling some initial speed. It's going to collide with object M2, which is at rest. And then afterwards, M1 and M2 are both traveling some speed. If it's elastic, then the initial momentum equals the final momentum, and the initial kinetic energy equals the final kinetic energy. If it's inelastic, then only the momentum is conserved, only that one. If you want to expand it out, the expanded out terms are right there on your right. The initial momentum would be M1 V1 initial, and then afterwards it would be M1 traveling V1 final plus M2 traveling V2 final. The double subscripts are a little crazy, but you get the hang of it. And then the kinetic energy, remember, is 1/2 mv squared. So it would be 1/2 m1 v1 initial squared plus 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. A little ugly, but it is what it is. Awesome. So lucky for you guys, since we're not in person, we're not going to do this page. And we're not going to do this page. I don't think these lessons would go very well over the iPad. I would really wish I could do those with you in person. So that means we're just going to skip them. But I do want to do page 19 and 20 in this video, and then we'll call it a day. So this is an example problem where we have M1 traveling V1 initial, and it's going to collide with M2, and it's going to be at rest initially. We want to know, will the incident ball, which is M1, will M1 rebound, stop, or continue forward under the assumption that this is an elastic collision? Now, in theory, we would predict, but I'm just going to tell you. What this actually depends on is the masses. It depends on whether M1 is greater than, less than, or equal to M2. And depending on what the relationship between the masses is, will determine whether it will rebound, stop, or continue forward. So in order to prove this, what we're going to do is we're going to set the initial momentum equal to the final momentum on the left, and the initial kinetic energy equal to the final kinetic energy on the right. We're going to expand that out, and I'm going to solve both sides for V2F squared. When you do that, you get this whole thing equals that whole thing. So what we can do is set them equal to each other. So let's do that. M1 squared over M2 squared times V1 initial minus V1 final squared equals M1 over M2 V1 initial, whoops, that's not an I, V1 initial plus V1 final times V1 initial minus V1 final. All right, well, some of this simplifies. M1 over M2 can get rid of the squares right there. And then this square gets rid of that. So what we're left with is M1 over M2 times V1 initial minus V1 final equals V1 initial plus V1 final. Now I'm going to reorganize this so that all of my V1 initials are on one side, all of my V1 finals are on the other. When we do that, I could then pull out the V1 initial and the V1 final. And what I get, I'm going to skip some steps, V1 initial is going to be M1 over M2 minus 1 equals V1 final times M1 over M2 plus 1. So again, I skipped some steps because I was running out of room. If you want to do algebra to get, all the way through, you have to distribute this and then put V1s on one side, V1Fs on the other side, and then pull it out. The reason I got to this point is because now we can analyze this equation in terms of the mass differences. So V1 initial is always positive. V1 final is what we're trying to figure out. Is that positive, negative, or zero? If it's positive, it's going forward. If it's negative, it's going backwards. If it's zero, the ball will stop. This whole term will also always be positive. So whether or not V1 final is positive, negative, or zero depends on whether this term right here is positive, negative, or zero. So what we can say is if M1 is greater than M2, that means that M1 over M2 is greater than 1. So when we subtract 1, we have a positive answer. M1 over M2 minus 1 is positive. So V1F is positive, so it continues forward. Whereas if M1 equals M2, then M1 minus M1 over M2 minus 1 is what? That would be 0. So V1F is 0, so it will stop. And then if M1 is less than M2, we have that M1 over M2 minus 1 will be negative. So V1F is negative, which means M1 will rebound. That was a lot, but conceptually, let's think about it. If M1 is way bigger than M2, it's going to keep moving forward. Whereas if M1 is really, really, really small, when it hits M2, it's going to go back the other way. And if they're equal in mass, then when M1 hits M2, M1's just going to stop and M2's going to go. Hopefully that makes sense. Again, it's not fun not being in class. I have a demo. I could literally show you this. We could get two objects out and have them collide, and you would see that this happens. But we're just going with this for now. Woo! All right. Good news is the last page is really quick. Inelastic collisions I've already kind of talked about, but here's your formal notes for it. Elastic collisions conserve kinetic energy. So inelastic collision is when kinetic energy is not conserved. So inelastic, kinetic energy not conserved. And this was the example I talked about earlier. If you drop a ball and it does not get to the same height, kinetic energy is lost. So it is inelastic. If you drop something and it does not rebound at all, we call that completely inelastic. You've already done completely inelastic problems. When you have M1 colliding with M2 and then they stick together after, remember how we said that it's M1 plus M2 as your final situation? We've done those problems before. Those are called completely inelastic problems. So now, instead of the problem saying M1 collides with M2 and they stick together, the question can just say M1 collides in a completely inelastic collision. And what you have to know that means is that they stick together. So it won't actually say they stick together. It'll say it's a completely inelastic collision, and that just means that it does stick together. Make sense? Hopefully. That was a lot. I talked fast. I'm sorry. Hopefully it made sense. Watch it again if it doesn't. Email me if you still have questions afterwards. And I have office hours now, so you can stop by my office hours if you have even more questions, or just email me. Whatever you want to do is good by me. All right. There's only one page left. We're going to do one page on tomorrow, and then we're going to review for the test, and then test. Then we're moving on. All right. Have a fantastic day, and we'll see you guys later.